In this video, we start our work with multiplication of polynomials. We're going to do two different topics. We're going to show you how to multiply a polynomial by a single term polynomial. We call those monomials. And then we're also going to show you how to multiply binomials. So those are polynomials that have two terms. We're going to show you how to multiply binomials by using the FOIL method. So the first set of examples that you see here, we have a polynomial of three terms. So here's our trinomial, and we're multiplying the trinomial by a monomial, a single term polynomial. So we will be using distributive property to multiply the monomial times every single term that's in the trinomial inside the parentheses. And when we multiply these terms together, we're going to be using our property of exponents, our product rule, so that we can multiply those powers of x. So when we multiply 3x to the fourth times 4x squared, multiply the two coefficients for a 12, and then using the product rule with our x's, we know that we have x to the sixth because we keep the base and we add the exponents. Going to the next term, now 3 times negative 4 is negative 12. And multiplying x to the fourth times x to the first, we know that we have x to the fifth, once again using the product rule. And in our third term, we're going to multiply 3 times 2, and that's going to give us a positive 6. And then we have the x to the fourth. That's our final answer, because we know that when we're adding and subtracting terms in a polynomial, we cannot combine terms that have different powers of the variable. So we're done. This is another trinomial, degree 6. A little bit of review there. Example number 2, we're once again going to multiply that monomial negative 6x cubed times the trinomial 2x squared minus x minus 5. And we're going to use the distributive property once again in the product rule when we deal with the powers of x. So we get negative 12 x to the fifth. And then distributing the negative 6x cubed times a negative 1x, we get a positive 6x to the fourth. And then multiplying the negative 6x cubed times the negative 5, we get a positive 30x cubed. Again, a trinomial for answer. None of the terms are alike because they have different exponents, so we're done. In our third example, our monomial has two variables. It's 4xy is a monomial, and our trinomial, once again, also has two variables. So we're going to go ahead and distribute the monomial to multiply times every term in the trinomial, and we're going to use product rule when the bases are the same to multiply the powers of x or y. So 4 times 3 is 12 for our coefficient, and here we get in our first product x cubed, and then we have the extra y from the monomial hanging on. Now we multiply 4xy times a positive 2xy. We get that 4 times 2 is 8. X times x is x squared, and y times y is y squared. And for the final product, we get negative 4 times negative 1 is a negative 4. There's no x, so we're just going to bring over the x from the 4xy, and then y times y squared is y to the third. None of these terms are like terms, so this is our final answer. Now, when we multiply binomials, because that's what we have here, we have a binomial x plus 1 being multiplied times a binomial 2x minus 2, then we're going to use that distributive property twice. We're going to take the x from the first term and distribute it times both of the terms in the second parentheses, and then we're going to take the 1 from the first binomial and distribute it times both of the terms in the second parentheses. So this is what we get. I'm going to write some middle steps here. So we're multiplying x times 2x minus 2, which is 2x squared minus 2x. Okay, and that's where we distribute the first x times both terms in the second parentheses. Then we're going to multiply 1 times the 2x minus 2. And so that's 2x minus 2, of course, as you know. And now we do have some like terms here in the middle, and I've kind of lined them up here, the like terms. And so we have 2x squared, but here negative 2x and a positive 2x gives us 0, and then we have the minus 2. Let me show you a shortcut for this work that we just did with the distributive property. And I'm going to show it to you with the second example. So first step would be to take the 2x from the first binomial and multiply it times both terms in the second. And I want you to notice what happens here. When I multiply this 2x times that 2x, I am multiplying together the first terms in both parentheses. So first terms in both parentheses. So that gives me 4x squared. Then I'm going to distribute the 2x times the negative 1. Those are the outer terms in the parentheses. Those are the terms that are to the outside. So that gives me 2x times minus 1 is a negative 2x. Then I'm going to go ahead and distribute the negative 3 times both terms in the second parentheses. So negative 3 times 2x will be my first product. And notice that there I am multiplying the inside terms, the inner or inside terms. I'm running out of room, so I'm going to line these up because I get a negative 6x, which is a like term with a negative 2x. Finally, I'm going to take that negative 3 times the last term here, the negative 1. And so now notice that we are multiplying together the two last terms, and that gives us a positive 3. And then combining like terms here, I get 4x squared minus 8x plus 3 as our trinomial answer. What I wanted you to notice here is this. You've probably heard the word foiling, and here's where it comes from. The f from multiplying together the first terms in each parentheses. The O comes from multiplying the outside terms, so that would be the 2x with the negative 1, so those are the outer or outside terms. The I comes from multiplying the inside terms, which would be the negative 3 times the 2x. And then the L comes from multiplying together the two last terms. So you will often hear people say, oh, I'm going to FOIL that. And that's what they mean by that we're going to multiply two binomials in this way. So let's FOIL number 3, give you a little practice. So first terms, when we multiply those two, we get 6x squared. Outer terms, now we get a negative 4x. Inside or inner terms, now we get a positive 15x. And that's our I. And then last terms, now we get a negative 10. And we're going to combine like terms that are in the middle. Those two middle terms are alike. And so then we get 6x squared plus 11x minus 10, which is a quadratic trinomial. And just wanting to get you ready, when we go to graph quadratic functions, they're going to have a parabola as a graph, but just wanting to get you ready. Let's go to number 4. And now in number 4, we once again have two binomials, but we have two variables. However, the process is still going to be the same in that we're going to use our FOIL. So we're going to multiply the first terms together, and that gives us 12x squared. Then we multiply the outside or outer terms together, and that gives us a negative 20xy because we're multiplying the 4 and the negative 5, and then the x and the y are different bases, so we just put them together. Then we go to the inside terms, and now we have here a positive 6xy. And then we're going to multiply the last terms, and now we get here a negative 15y squared. Be careful to recognize that you have a y times a y, which is a y squared, because sometimes my students forget that. All right, so now we do have some like terms in this product, don't we? In this answer, these two middle terms are alike. So let's go ahead and combine those. So 12x squared comes down, and here we have a negative 14xy. Notice I just dealing with the coefficients. When I combine like terms, I'm not dealing with the variables on the x and the y, right? And so here we have our answer for number 4. Okay, number 5, same idea. Here we have our two binomials. They have two variables, but we're going to go exact same thing. We're going to multiply the first, so that's going to give us 3a squared. The outside gives us a positive 3ab, a times b. Okay, and then looking here at the inside, we have a 3 times a negative 2. That's a negative 6ab. And you could have written ba or ab because they mean the same thing. The order in which you put the letters does not matter. Okay, and then we're going to multiply our last, and we have a negative 6. But see how we have b times b? So that's b squared. Okay, these are your middle terms here. They are like terms. So let's go ahead and combine. So 3a squared, And then here we get a negative 3ab, and we have our negative 6b squared, and no like terms remaining, so that's our final answer. Now in number 6, notice that we have two binomials being multiplied times a monomial. So there's 3 different polynomials that are multiplied together. And the easiest way to do this, in my opinion, is to multiply together the 2 binomials first, to get those out of the way, and then we can distribute the 3y, the monomial, last, and it'll keep your numbers a little bit smaller. Now, you can go left to right if you'd like. You could go 3y times the 3y plus 4 and just start there, and then multiply times the y minus 1. But I notice that my students get the answer correct more times when they multiply the binomials first. So that's what I'm going to do. So we'll do the first here, which is 3y squared, outer, which is a negative 3y, inside, which is a positive 4y, and then the last, which is a negative 4, and that I'm bringing down the 3y that I haven't used yet. Then I'm going to go ahead and combine these middle terms first before I take care of that outer 3y. So I get 3y squared, and here I get a plus y minus 4. And now we're ready to distribute that monomial, right, on all 3 terms. So we get 9y cubed plus 3y squared minus 12y.